In the previous lecture, we defined the first three trigonometric ratios, sine, cosine, and tangent. In this lecture, we'll define the next three. Let's review. Given a right triangle with an acute angle theta, we defined the following trig ratios. Sine of theta is opposite over hypotenuse, cosine of theta is adjacent over hypotenuse, and tangent of theta is opposite over adjacent. And if you remember that little saying, some old horse caught another horse taking oats away. If you can remember that, you're in good shape. Okay, so what we want to do now is define the next three. Okay? Well, the next three are going to be cosecant, we'll abbreviate it CSC, secant, and cotangent. Now, all these are is reciprocals of sine, cosine, and tangent. For example, cosecant theta is equal to 1 over sine theta. Well, sine theta was opposite over hypotenuse. And if you divide 1 divided by opposite over hypotenuse, it's just going to invert the bottom fraction. Okay? So cosecant is just the reciprocal of the sine. Okay? Similar, secant theta will be 1 over cosine, and cosine is adjacent over hypotenuse. 1 over that is going to be hypotenuse over adjacent. And similar with cotangent, tangent was opposite over adjacent, so cotangent will be adjacent over opposite. Okay? So you might want to write this down somewhere in your notes. So let's go through these again. Sine opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent, and these are just going to be reciprocals of sine, cosine, and tangent. We invert our fraction here. This is hypotenuse over opposite, hypotenuse over adjacent, and adjacent over opposite. So try to memorize these three, okay? And then these three are just reciprocals. So let's do a typical example. Here's a right triangle. We want to find the 6 trigonometric ratios for this triangle. Well, of course, we need 3 sides to figure out the ratios, so we have to figure out what this missing side is. Here's theta. We want to figure out what the opposite side of theta is. Well, that's no problem because we know the Pythagorean theorem. I can label this A for now. I know that A squared plus B squared is equal to C squared, so maybe we'll do this here. A squared plus B squared is equal to C squared. We'll solve for A. A squared plus 4 is equal to 25. A squared is equal to 21. So A is equal to square root 21. Okay. And now we have all 3 sides. So now we can find all 3, or all 6 ratios, rather. Okay, so let's find these 3 first. Sine, that's opposite over hypotenuse, so opposite is square root 21 over 5. Cosine theta is adjacent over hypotenuse, and tangent is opposite over adjacent. Okay, and now we have to do the other ones, so we have cosecant, secant, and cotangent. Remember, cosecant is just the invert. We invert the sine ratio, the reciprocal. So cosecant is going to be 5 over the square root of 21. Secant is a reciprocal of cosine. So I'm just inverting all my fractions. And cotangent is a reciprocal of tangent. Okay? You don't want to say the inverse, okay, because we'll do inverse functions later. These are the reciprocals. We just flip the fraction around. Okay, so nothing to it. If you know what the sine, cosine, and tangent are, you automatically know what cosecant, secant, and cotangent are. So again, the big thing you have to remember is this. You have to memorize this because you're not going to be able to use your notes when you're taking your quizzes or exams. You might want to review these lectures a couple times until you feel real comfortable with them, and then try all your homework problems.